So we're going to start today with a review. So let's just say if I have 2 and 2 and 1/2 and 2. The first thing I'm going to say is, what's the odd man out? And hopefully everybody said, oh, well, that's easy. 2 on 1/2. It's the one that's different. So it doesn't matter if you're going to fill in a blank here or if you're going to fill in a blank here. This is the one that's different. Okay? This is greater than 1. So it's going to make that side greater. Okay? So here it's this side. Here it's this side because there would be a multiplication side here. So on this one, it's going to make that side greater. On this one, it's going to make that side greater. Okay, so it's all in how you write it. I prefer this method, but it's all in how you write it. Next bit of review. So anything with a whole number and a small piece, whether it's a decimal or whether it is a fraction, anything that has a whole number is greater than 1 if it has any extra little pieces. So that goes for decimal something or mixed numbers. Now let's work with fractions. Proper fractions, improper fractions, and fractions that are equal to 1. Okay. We always just look at the top number. Is 1 greater than, less than, or equal to 1? It is less than. You do not need to keep these notes unless you think it will come in handy. Is 6 greater than, less than, or equal to 1? And these top numbers don't have to be 1. They could be 4. Okay. Is 4 less than, equal to, or greater than 6? Well, it's less than. Is 6 less than, equal to, or greater than 4? Well, it is greater than. So when you're looking at whether it is greater than, less than, or equal to 1, you're looking at it, the numerator compared to the denominator. How many pieces do you have out of versus how many pieces it was cut into? And then the last one, 6 is equal to the bottom, so it is equal. Once you can do that, then you come back up here and just look for an odd man out whenever it's a fraction. All right, so that's a good review. So let's look at today's work. Always read the directions. Complete the table by multiplying, then rewrite the equivalent fractions. Equivalent. If you look at this column here, these are all fractions that are equal to 1. Therefore, when we multiply, then your new answer is going to be equal to 3/4. We did this when we were finding equivalent fractions, when we were doing adding and subtracting. Remember, we multiply the top by the top and the bottom by the bottom. And that's all we're doing here. 3 and 3, 9. 3 and 4, 12. 5 and 3, 15. 5 times 4, 20. Okay, I want to let you guys do the last one. Okay, 10 times 3, 30. 10 times 4, 40. Now what? You can rewrite them, but it's just as easy to do this. Because what it means is 9/12 is equal to 3/4. They look different, but we multiplied it by a 1, so they are literally the same. Okay, so let's move on to this middle section. Again, step 1, find odd man out. 2, compare him to 1. 3, write that answer. The most common mistake is not comparing it to 1, but comparing it to the other number. All right, so let's see. 1644. Odd man out. We'll go straight down. Okay. 2 over 2, 8, 8. Well, 2 over 2. Okay. I'm going to stop there. And I'm going to come over here and do 12. 5 over 3, 6, 6. Well, same, different. All right. So those are my 3 examples I'm doing with you. These are all fractions, so I'm just going to compare the top to the bottom. 1 over 6. 1 is less than 6, less than. 2 over 2. 2 is equal to 2. So it's equal to 1. And the last one, 5 is greater than 3, greater than. Okay, so you can do the rest. Pause this video now. Great, so let's go on to 19. Which expression has a product greater than 2/3? Okay, so that means that what you're actually trying to do is find a statement where this is true. Okay, we're comparing it to 2/3. So what it means is, you don't have to write this on every one, but you're not picking 2/3 because it's the one that's the same. It means you're just looking at the odd men out. And greater than means you're looking for something greater than 1. For fractions, you compare the top to the bottom. This is 1, so is it greater than 1? Process of elimination says no. Okay, is 1 greater than 4? No. Is 5 greater than 5? No. Is 5 greater than 2? Why, by George, yes it is. Okay, on this one, an expression that has a product equal to 9/4. So are you going to pick 9/4? I see 9/4 here, and I see 9/4 and all there. Can that be the odd man out? No. You're going to pick the other number and look for one that's equal. Try to find it now. All right, so since we're not picking the 9/4, it leaves the other numbers. We're looking for one equal to 1. 5 is greater, 2 is greater, 1/2. 1 is less than 2, but 10 is equal to 10, so it is B. Shh. Okay, the 2 on the bottom. Remember, 4, 3/4, 4. Set it up. 4, 3/4, 4. Everybody can set that up. Okay. Odd men out. I didn't even read it. That's just what we're doing this week. And if I did read it, it says, does the chef need more than or less than, so I'm going to find out, 4 cups. Odd man out, it is 3/4. 3 is less than 4, so it will be less than. And to explain, it's because 3/4 is, you guessed it, less than 1. Okay. Okay. So on this one, it says how can we estimate the product? Well, let's think about what we do know. 2 over 3 times 6. We're going to compare it to 6. And 2 over 3 times 6. And we're going to compare it to 2 over 3. Odd man out. 2/3, 6 and 6, 2/3 is odd. 2 over 3, 2 is less than 3, so this one's less than. 2/3, 2/3, 6, odd man out. 6 is greater than 1. So the product will be right here. This is all the information we've got. It will be greater than 2/3, but less than 6. So it will be somewhere between 2/3 and 6. I know that's kind of odd thinking, but it really tells you where that product is going to lie by comparing it to each of the numbers in the number sentence. All right. Happy math. See you tomorrow.